Welcome back to my course Aspects of Biochemical Engineering. So, we are almost coming to the end of our course, and this topic today I have chosen, that is the economic analysis of the biochemical process. As you know that this is the major concern about the industrial processes, because whatever thing we develop, that we want to apply it, but that should be economical. And if it is not economical, we cannot use for the benefit of the society. So, question comes, how you can do the economic analysis of the processes, and it is something similar to the chemical process also, but let us see how we can do that. Now, any industry, whenever we operate, we come across two type of expenditure. One is what we call fixed expenditure, and then we have the operating expenditure. The fixed expenditure on the basis of the installation of the plant and other things, that for you have some kind of installation cost, and that money usually we take it from the bank as a loan. So, we have principal amount, we have interest that we shall have to pay per month, or and then for operation of the industry, we have different other operating cost. Operating cost comprises of maybe the raw material cost, maybe the other utility cost. Different type of utilities we have. We required electricity, we require steam generation, we required maybe the soft water, and that air compressor, that different type of utility that we required. And plus we have the manpower that we have. All these things you have to consider, and then our output is our product. So, if you know that how much product we are producing per day, and we know that how much money we are spending per day. So, if the cost of the product is more as compared to that money we spend in the industry, we call it profitable industry. Now, if it is other way, if the cost of the product is less as compared to expenditure, then we consider as a sick industry. So, then let us see how we can do the analysis, do the economic analysis of the biochemical processes. The first thing that is important, that what is called economic assessment. The basic objective of a fermentation process is to yield a product which is predictable and economically viable. So, this is very important, that our objective should be that it should be economically viable. For developing such successful commercial bioprocess, following criteria should be met. What is the low capital investment? Provided that the equipment is reliable and can be used range of fermentation process. Let me tell you very simple, that suppose if you use the lot of equipment that is already available in the industry, the different fabricators. So, if you use those equipment, obviously it will be very little bit cheaper. If you use the custom made system, naturally it will be very costly. So, that you have to think about that, what should be the material of construction, what kind of reactor that we use, that is very important. That is the low capital investment. Then cheap raw materials. When you call cheap raw materials, not only with respect to availability, availability also very important. Suppose if the material is cheap and it is not available, and it is no good. So, usually we found that if you have multiple choice of substrate, then availability of the material will be very good. High yielding of strain of microorganisms should be used, and I told you that industry we use the industrial strain. What is the industrial strain? That can have the higher yield. I told you that that if the concentration of product is more, then our recovery cost will be less. So, what is our desirable thing? That our concentration of product should be as high as possible, and that should be consistent. It is not that one batch you have some product concentration, second batch you have less concentration, that is no good for our process. So, that we shall have to look into. low labor cost and use of automation whenever possible. I told you that if you the batch process is very easy to operate, and we don't require much of skill for the operation of the batch process. But what is the disadvantage of the batch process? The yield, the productivity is very less as compared to the continuous process. So, we always look for continuous process. In the continuous process, our productivity is very high, and not only our productivity very high, but also that the manpower requirement is drastically reduced. It is reduced to almost 1/10. So, that is one of the important factor. The recovery and purification procedure should be simple and rapid. That is also very important. How simple we can separate it out the material, that product, and minimize the effluent discharge. Because if you I can take the example of biosteel process. But if you look at the lot of because India has more than 250 distillery, and most of the distillery they are operated in the batch mode. In the batch mode, we usually if the alcohol concentration is 7 to 8%, we have found that 13 liters of effluent is produced per liter of alcohol production. But that now if you increase the concentration of product, obviously the effluent production also drastically reduce. And then biosteel process is such a process, they have a recirculation device, and through which they prove that this amount of effluent generation is reduced to 1/10. So, this is very important, and heat and power should be used efficiently. How efficiently we use the heat and power, minimum space requirement, that is also very important, and is complied with safety guideline and the regulation. These are the all things we shall have to take into consideration for the economic assessment. Now, if you look at the in the bioengineering process, first we have the flow diagram, and then we find out what is the equipment price and volume of mass of the product that we find out from the raw materials, utility, labor and consumables. This we find out what is the operating cost. The operating cost, we have all these factors. Capital cost will be this one. This is equipment cost, and that will mostly comes on the not only equipment including the reactor, pump, valve, all these things included, all the downstream processing processes that comes under the capital cost. Now, outcome of the economic assessment, if you look at the estimation of capital cost, that we shall have to build a new plant, that we shall have to do. The estimation of the operating cost, combination of capital and operating cost to provide the several types of composite values reflecting the process profitability. I told you the capital cost, and when you make any capital cost, we take the money from the bank, and then we have two things. We have principals as well as interest. Both you have to pay per month, that you have to add with the operating cost, and then match with your cost of the product. And selection of the best process by competing alternative, estimation of economic value of making process changes and modification to an existing process, and quantification of uncertainty when evaluating the economic potential of the process. Now, Goss breakup, as I pointed out, the preliminary economic evaluation of a project, that in manufacturing of biological product usually involve the capital investment, operating cost, and analysis of profitability. These are the three things we shall have to do it. I have some example at the end. I shall show you how we can do that. Goss breakup can help in observing the biggest potential saving, and depending upon the cost breakup, development of the component and that contributes most of the cost of the product can be performed. As for example, that if the raw materials are a major part of the total cost, then the media and microbial strain improvements research should form major part on a development program. So, this you have to find out which plays crucial role in the cost distribution process. Now, here example of the Goss breakup, we have this table gives you some information that in case of beer making industry, what is the raw materials contribute and other labor and supervision, fixed charge, maintenance charge, how is contributed. Then acetic acid industry, how it is contributed. This is the citric acid industry, how it is contributed. The then nodes protein, this is single cell protein, how it is. Penicillin, how it is there. TPA, how it is there. That distribution has been shown here. The market potential is very important. Before designing the production plant, the market potential of the product should be assessed, because this is very important. The three category of products we discussed at the beginning: the low value, high volume products, where that cost of the product is 1,000 to 10,000 per tons. US dollar, the solvent, biomass, and high fructose corn syrup. Then we have medium value, medium volume products. We have 10,000, 10 to the power 3 to 10 to the power 5 dollar, US dollar per ton. We have organic acid, amino acid, and biopolymer. High value, low volume products, we have 10 to the 5 to 10 to the power 7 per tons. We have enzyme, vitamins, antibiotics, and vaccine. So, market potential we shall have to find out. Then for the capital cost, how you do the analysis? The cost of the capital is investment, small facility using the range 30 to 60 million dollar, whereas for the large facility we required 100 to 250 million US dollar. The main includes, the first is your equipment, second is the installation, third instrumentation, building costs, labor equipment, laboratory equipment, and the electric and other requirements. So, these are the different things that we comes under the capital cost. Now, capital cost estimation from the table, you see that this is the penicillin estimated of 225,000 liter fermenter with accessories equipment. This is how this cost percentage of the total is given. Process equipment is 23.6%, installation is 5.2%, insulation is 1.9%, instrument is 2.7%, piping is 11.8%, electrical is 15.8%, building is 21. So, different cost distribution is given here. It can be observed that equipment costs are crucial in determining the overall cost of the process. The empirical relationship between cost and size of the equipment is like this: cost 1 and by cost 2 equal to size 1 by size 2 to the power n, where n is the scale factor. This is how this equation has been built up. Other factors that affect the equipment cost is the material of construction. I told you that in the fermentation industry mostly we use SS316 as a construction material. Instrumentation provided with the equipment, that also more instrument we use, more involvement will be, the cost to involvement will be there. Then operating cost depends on other several factors. Operating cost includes the sum of all expenses like raw materials, labor, utilities, waste disposal, and overhead cost. Dividing the annual operating cost by the annual production rate, yield, and unit production cost is the dollar per kg. For genetically modified product, the basic operation cost 10 to 30% of each increase in contaminant level. The other factors contributing to the operating cost is the sterilization, aeration, agitation, water usage, and recycling, and product recovery costs. Particularly, I want to tell you that in case of low value, high volume products, if you can recycle our effluent to the process, that water requirement of the process will be reduced drastically. What the biosteel process deals with. Now, operating cost, this is the contribution, this is raw materials, this is labor, consumables, laboratory the quality control, and the waste disposal, utilities, equipment dependent, and the miscellaneous. This is most of the, this is the direct expenditure and this is the indirect expenditure. This is the percentage contribution of this operating cost has been given here. Now, the operating cost, the raw materials accounts the cost of all fermentation media. This is important. This is the fermentation media, recovery of chemicals and cleaning media. That then for commodity biochemicals like ethanol, the cost of the fermentation media is more significant. High value products, the buffer used for the product recovery, equipment cleaning can be the major part of the material cost. The table provides the commonly used raw materials in the biochemical industry. The price of the raw materials can vary widely depending on the required purity. So, this is the raw materials that we have. We have carbon source, we have nitrogen source and other materials that we have, and this is the different concentration that we use, and this is the price, how much price is contributed per kg of product formation, per kg of this product formation that has been given here. Now, profitability analysis that I was talking about, the end of the day that we look for the profit. Now, with the estimates of capital investment, operating cost and revenue of a project, the profitability and attractiveness from a investment point of view can be assessed. There are various measures for assessing the profitability, which includes the gross margin, return on investment, and payback time, which are calculated. Now, as for example, suppose when we go for any kind of that equipment, that particular reactor, we always find out the life of the fermenter. Suppose life of the fermenter is 10 years. So, whatever money we have, that money we spend for the fermenter, that is to be recovered within 10 years. That is very important. That is the payback time is there. The gross profit will be net annual revenue. Annual revenue mostly comes by selling the product. Annual operating cost and the minus is the recovery cost. The net profit will be the gross profit minus income tax minus depreciation. So, gross margin is the gross profit by revenue, and that ROI equal to net profit by total investment into 100. ROI is the return of investment, and payback time is the total investment by net profitability, and all variables are average over the lifetime of the project. Now, let me give you a case study, so that the things will be little bit clear to you all. I have taken the example of the landfill gas generation process. Now, landfill gas generation process is found to be very profitable business as the western country is concerned. What they do, they take the city garbage and dump it in the downland. That suppose this is the downland, and then what they do that this downland they stabilize and they produce methane. And this is the kind of technique that I want to show you, how you can make the conventional that landfill gas generation process very fast. Now, this is the landfill area. Here we can spark the acidogenic organism here, so that the degradation of the solid material to organic acid will take place. This is acid recovery unit. You can recycle back again and again until that solid material is stabilized, and then this liquid, that volatile fatty acid, you pass through the methanogenic reactor to produce methane and carbon dioxide. And this, if you do this, you can reduce the time of fermentation process drastically. The age of any kind of landfill is about 5 to 10 years. And whereas we have found that if you do like this, we can make the solid stabilization within 40 days. So, it is very much attractive. Now, this is how the landfill processes operated in the landfill. This is the downland of this process, and here this truck comes in the weighing machine. We take the weight and it is unloaded here, and then again truck goes there. The difference will give you how much that waste material here they have downloaded, and then you do the shredding machine. Shredding machine means it's degraded into the small pieces, and then this is the magnetic separator, where we can separate the iron type of material. We get the ferrous type of material out, and then we put it in the landfill. Now there is a international sanitary law. International sanitary law says that whenever you put any kind of organic waste in the landfill, this should be covered with 6-inch clay layer within 24 hours. Otherwise, the gas will be generated from the solid material and pollute the atmosphere. That is the undesirable. That they follow. And when then what we do, that when it is totally filled up, then this is covered with about 18-inch thick this clay layer. So just to ensure no gas will go out from the system, then we make some kind of well here, and we can spread the acidogenic culture here, and here it has been shown this acidogenic culture spread on here, and then it reacts. All the acidogenic culture use the organic material and convert to the acid. It passed through the acid digester, and then it recycle back there, and this acid finally pass through a methanogenic reactor and produce methane and carbon dioxide. Now this is in practice in the landfill. This is all the pipeline. This is the well I was talking about, and this well we can apply this methanogenic formation. We can do in the well itself. If I applied any kind of vacuum in this line, then all the gas present in the landfill, that will come in the pipeline, and then we have some gas purification unit here. We purify the gas and send it for electricity generation. This is the gas turbine, and from that we can produce the electricity. Now this process, there is the analysis of the cost of this particular process. This has been done, and I want to give you some example that how they have done that. This is the rapid rise of the cost of the energy prompted the increased interest of recovery utilization of the landfill gas. Now for landfill, so what are the capital cost we have? We should have the compressor or gas chiller, that will cost you $103,000. Then wells and header, this is $376,000. Discharge pipeline $35,000. Then site works is $10,000. Instrumentation and control $100,000 US dollar. Electrical service is $20,000 US dollar. Engineering is $65,000. Total is coming $709,000 US dollar. This is the capital cost how they have calculated. And then the estimated annual operating cost, what they have found, what is the electric power consumption, on the basis of they have found out this is $90,000 US dollar. Compressor maintenance, it is $5,200 US dollar, 5% of the total cost. Maintenance labor is 8 hours per day at a rate of $15 per hour. It is coming about $43,800. Then administration and testing, on the basis of $2,500 per month, it is coming about $30,000. The amortization is the 7 years at the 12% interest, that is coming about this $155,400 US dollar. The total operating cost is coming about $324,400 US dollar. So this is the previous one is the capital cost, this is the operating cost. Now when we mix together, so we have direct sell, we sell by selling the gas. How much gas we produce? This is on the basis of 32,240 cubic meter per day, and that calorific value is 21 megajoule per cubic meter, and price is $2.32 US per gigajoule, and estimated cost is based on this $0.62 per gigajoule. That if we calculate, this is the direct sale we will get, and there is another cost that is there, what we call entitlement cost. Entitlement cost, since this is used the waste material, the municipality gives some kind of revenue, to some kind of money to those companies for safeguarding the environment. This is what you call entitlement cost, and total is coming like this. So this is the benefit, this is the total money we are getting, and this is the total money we are spending, and so the net profit is coming about 329,600. This is how we can do the calculation. The above table, it has been found that total investment money can be recovered within less than 3 years. So I told you the age of the landfill usually 5 to 10 years. That means remaining 2 years to 7 years they can run with profit. Now there is another enzymatic, that pure system that we work out, that how you can find out the economy of the process. Let us see, this is little bit different as compared to what we have done in the previous part. An enzyme is used to convert the substrate to a commercial product in a 1600 liter batch reactor. Vmax of the enzyme is given, Km is given, Km is the Michaelis-Menten constant. Substrate concentration at the start of the reaction is 3 gram per liter. According to the stoichiometry of the reaction, the conversion of 1 gram of product, 1 gram of substrate produces 1.2 gram of product. The cost of operating of the reactor, including labor, maintenance, energy and other utility, estimate to be $4,800 per day. The cost of recovering of the product depends on the extent of substrate conversion and the resulting concentration of the product in the final reaction mixture. For conversion between 70 to 100%, the cost of downstream processing can be approximated by this equation. This is the downstream processing cost, where C is the cost of dollar per kg of product treated and X is the percentage of substrate conversion. The market price of the product is $750 per kg. Currently, the enzyme reactor is operated 75% conversion. However, it is proposed to increase this to 90%. Estimate the effect this will have on the economy of the process. So the problem is very simple, that that we are operating the process at the 75% substrate conversion, and now the industry want to increase the conversion to 90%. Now question comes, if we increase the 90% conversion, is it possible to increase the economy of the process? Because that we shall have to find out in this problem. So let us see how you can find out. As I pointed out, whenever you solve any kind of problem, first you have to jot down that what are the data given. The volume is 1600 liters. The Vmax value is given, Km value, S0 value, operating cost is given, and market price of the product is given. Now 75% substrate conversion is there. That means 75%. What is the S value that we have? S value will be for 75%. That means 25% will be remaining. 0.25 into S0. S is how much? 3 gram per liter. So S will be 0.75 grams per liter. So for here for S0, this is 3 gram per liter. To convert to 0.75 gram per liter, question comes, what is the batch time is required? This batch time we have calculated, this correlation already we developed before. I don't like to solve it again. So we can put the values Km, Vmax, S0 by S, we can find out the batch time. This is 4.81 hours. Now, therefore, the operating cost will be what? Operating cost we easily find out that how you can find out that per day, that then this is per day, am I right? So, this hour per day will be divided by 24. You can so you can find out that 962 is the operating that cost for the per batch. Now, the cost of downstream processing will be this. This equation is given. If we put the value, we can find out the downstream processing cost. The mass of the product form is determining the mass of the substrate consumed. That is the mass of substrate consumed. How you can calculate? S0 minus S into V. S0 is 3 minus 0.75, and what is the volume? 1600. So, 3.6 kg. Mass of the product, because we have already find that 1 gram of substrate produces 1.2 gram of product. So, this is the amount of product we will get. Therefore, downstream processing cost will be what? This is per kg, we have $130.25 per kg. So, you multiply that, we will find this. So, the revenue from selling the product will be what? This into this, am I right? Because per kg product the cost is $75. So, you can find out $3,240 we can recover. Now, therefore, the gross profit 75% is the revenue is the 3,240 minus operating cost this minus downstream processing. So, it is coming like this. Now, similar type of cost analysis we try to perform when we have 90% substrate conversion, and then we find the batch time requirement will be 6.84, and if it is 6.84, then operating cost increases to this, and then we can find out the downstream processing cost is this, and then we find out that what is the substrate consumed, we find out this, that increase to this, and the product value also increase. Now, the product cost is downstream processing cost is this, and product value is this. So, revenue will be how much we are getting? 1,868. Now, if you look at before, we how much we got? 1,715. Now, what we are getting? 1,868. So, thus the gain of the per batch by increasing the substrate conversion is $153. So, then the gain of the 9% increase in the Goss benefit that we observe, because you know that this is how we can analyze the process, that find out the economic that you know viability of the process. So, this is a very interesting problem, and through which we can find out by increasing the conversion efficiency how much profit we are going to get in the some cases, not necessarily all the cases your profit will be increased, some cases the profit will be decreased also. So, in that case we prefer to maintain our that conversion efficiency little bit less. So, in this particular lecture I try to do the economic analysis, which is appears to be the most important, and as per biochemical industry is concerned. So, I told you the two type of expenditure we have. We have capital expenditure, we have operating expenditure, and from that we can find out that what is the cost involvement of this process, and from selling of product we can find out how much that the money will gain out of that, and there is some other factors we shall have to consider as per income tax and other things revenue is concerned. So, when you do the calculation of the profitability of the industry, you have to take into consideration of all the factors, and then we can find out how much profit we can have in a particular industrial operation. I try to discuss one case study, that landfill gas generation process. If you operate for 3 years, we find that whatever money we spend for this process can be recovered, but age of the landfill is more than 3 years. So, we can run the remaining years with full of profit. So, and one enzyme conversion process, enzymatic conversion process I try to discuss, and there we find as we increase the conversion efficiency, the profitability of the industry will increase. Thank you very much.